So in this video, we're going to go over lecture number 16. So lecture number 16 is going to be a self-tutorial of Matlab, specifically to solve beam element problems. So in order to get started on this lecture, you need to go to the Canvas site and you need to go down to lecture number 16. All right, and you need to download the FEA tutorial file and the handout file. So if you do those two things, what you should have is, if you go to the handout, actually, and then the third thing that you should look at actually is the homework number 6 tutorial. So if you go to homework number 6, it should be at the very bottom here for homework. So you get homework 6, download that as well. Okay. So what you'll end up getting is and open all these files. So in Matlab, you should have the FEA tutorial, and then in Adobe, you should have both your handout here, and you should go to topic 49. Okay, for your self-help tutorial, and then for tutorial 6, and then you should have tutorial 6 and go to problem 2. So what in today's class is doing is we're going from we're going to we're going to solve this problem that's already, you're given the solution by hand, but you're going to solve the problem using MATLAB. Okay, so the MATLAB code that you're given here will, if you hit run, so once you have the code downloaded, you hit run. All right, so you can say change folder, that's fine. You hit run, and it should, everything going smoothly here. What it'll do is you won't see anything output in the command window, but you'll get a bunch of variables. So these variables are the answers to your finite element problem. So if you want to look at a specific set of variables, you can look at, for example, you can look at this example here. You can look at you can look at here. So you can look at, like, this is like all the forces and moments, and then you can find like all the known degrees. You can define all the degrees of freedom. So if you look at where is it? These are your degrees of freedom in your case, and then you have like your global stiffness matrix, which is your K value here, and all these things should align with what you have in the tutorial file. So basically, for the tutorial, you define the stiffness matrix individually. You then define the global stiffness matrix. You can then reduce the matrix down to just the unknown displacements and slopes. You can then use the inverse to solve for those displacements and slopes, and then you can find the stresses within the elements. So you can do that using the stiffness matrix that you're given, and now the known displacement matrix. And you can then solve for the rest of the you can then use the moments at our nodes to then solve for the stresses. So the code follows the same exact process, but the neat thing about the code that you can play with is that you can actually vary the number of elements. So you can vary the elements on to the left of the applied load, and you can vary the number of elements to the right of the applied load, and the code will continue to run. So that's one of the cool things about that, and what that should give you is that the more nodes that you run, the more of a continuous picture of the beam that you'll get, and you should end up getting a solution that would be pretty similar to a continuous solution that you might get if you had looked at um, the uh, the handouts solution. Okay, so this is like the continuous solution for a fixed beam with a midpoint, a load in the midpoint. So if you evaluated this, you should end up getting, if you had a lot of nodes, you should end up getting like the deflection and the slope along the beam that you calculate in your finite element should end up getting pretty close to these values if you use enough nodes. Okay, so um, so hopefully this tutorial would be a good introduction to the Matlab code. Um, if you have any questions about any parts of the code, this is something where I'm going to just scroll through the code really quickly here. And you can just let me know if there's any part of the code. Sorry, let me go to the actual code in Matlab here. I'm just going to slowly scroll through this. So right now I'm highlighting lines 1 through 25. Now I'm going to scroll down, and now we have lines 28 through, keep 25 up here, but lines 25 through 40, really. And then I'm going to go down to lines 41 through 68 here. And then I'm going to go down to line 72 here. And you can look at this code here. And then the last one would be lines 97 through lines 123. Okay, so just pause the video if that was too fast and you can see the code. But if you have any questions about any of the particular lines in the code, feel free to reach out to me and we can talk about it, set up a time during office hours or something like that. All right, but the major thing you're going to do is you're going to use the handout. You're going to have you're going to try to identify all these parts of the code within the handout. All right, and then the last few things you need to do is you need to create like you need to find the stress, and you can play with the number of elements that you have in the system, and you can try to compare your results that you get with the continuous solution that you have for the system. Okay, so so this is really just meant for you to learn. You're going to use this code, or you can use it, you can modify this code in a future computational assignment. So the better that you can try to understand the coding process, or for how you can develop a MATLAB code where you can vary the number of elements, the better you're going to be served on that computational assignment.